Hello, hi. Shall we start? Yeah? I hope you're not tired because I am. So who attended my workshop today? No one? Only two? You are the best. Okay, I'm just kidding. Okay, so essentially I had a workshop today and I'm also the backup speaker because someone dropped off or was sick, I'm not sure. So I turned my workshop into a presentation. It's not a big effort. You will see that actually this presentation is the core of my workshop. And I want to talk about orchestrating large language models with CrewAI, also known as agentic AI. So we will dive into how to create agents, how to do it with CrewAI, which is a Python package. And most importantly, all the things that I'm going to show you are about designing agents, so designing application with agents. Of course, this is a very is a very hype argument now because it's a very hype topic, and a lot of companies are trying to talk about agents and to dive into this agentic AI. I'm an engineer, I'm a builder, so I like to build stuff, I like to build solutions. For me, it's not about hype, for me, it's about finding something that I can use to solve my problems and to achieve my goals. So we can also talk about the more ethical part regarding agents, reasoning, all these things. But the focus of this presentation is building stuff, potentially things that in the end will work. This slide is for you. I'm really approachable. If you want to ask me questions later or after the talk, and if you hate data science, we can also talk about music. I'm really into music. So there are many things we can talk about. In a nutshell, I'm a data scientist, as I said today, or AI engineer. I'm not sure anymore. I don't know. I'm a bit confused about these new words and these new roles. Essentially, as a data scientist, as I said, I want to make things work. And CrewAI, as we will see, is one of those things that I look at it, I'm like, okay, I think I can build something. I think I can find some solutions where I can apply this library. All right. Let's start with some history, even though this doesn't really go back in time, because what happened a few years ago, many years ago, is that OpenAI released ChatGPT to the consumers, and we were all amazed and hyped, and that changed the world. I mean, we can say it for sure that that move changed the world, and a lot of companies followed after ChatGPT, after OpenAI. And if we can think of how LLMs work in a nutshell, we have this pre-trained large language model, we give it a query, and then we get an answer. And this answer is based on the training process that happened against the LLM. I don't know if you remember when people were trying to ask ChatGPT, like 4 years ago, they were asking ChatGPT things that were not part of the pre-trained model, like who is the president of the United States? And of course, ChatGPT didn't know anything about that, and people were making fun of it. I remember LinkedIn was flooded by posts of people saying, oh, look at it, it's such a smart model, but it doesn't know who is the president of the United States. And of course, the problem was that ChatGPT was not trained against those information. It's really simple. If you're not training the model against those information, you don't have them in the model. And then we moved to compound systems. Who is familiar with RAG? Just a bit. Okay, so essentially RAG is like a database. It's this vector, really nice. It's also a vector database, but essentially is this retrieval augmented generation. It's something that we put on top of the LLM. Let's assume you're asking something to the LLM, and that question is also involves looking into your Google Calendar. The LLM, of course, doesn't know anything about your Google Calendar, doesn't know when you are on vacation, right? So you ask something to the LLM, but unless those information were part of the training, the LLM doesn't know anything. What do we do is doing this retrieval of some information that are not part of the training, so the LLM can look into those information. So the question is, hey, I want to do that, and please answer based on my availability. And the LLM will look into a retrieval augmented generation system, and thanks to this compound system, we will retrieve those information. So we can add more to the training phase. And then we move to LLM agents. In a nutshell, who is implementing agents here? Who has some experience? Okay, apart from the nice people that came to my workshop, of course. But who else? Okay. It's nothing complicated. It's nothing new. I was studying agents years ago before LLMs. In a nutshell, what we can say about agents is that we have the LLM, and we don't get the output of the LLM right away. But what we do is using some sort of thinking loop. And this thinking loop is something, you can think of it, is the same thing that you say when you tell someone count up to 10 before say something. And this is the thinking process. And what happens is that the LLM, which is the core thinking process, is also using some tools. For instance, can browse the web, and is also picking some tasks based on whatever we want to solve. And the interesting thing about it is that we're not using the LLM right away, but the LLM is part of the solution. The LLM is the thinking process of the agents. So this simple loop is a thinking process under the hood that happens because of the LLM. And the nice thing about it is that we have external tools. We have RAG, we have tools that allow us to browse the web, to open a directory in our system, and so forth, so on, depending on what are the actions that we want to give, what are the powers that we want to give to the agents. And the most important thing you should know in order to understand how agents work is agents versus dynamic systems. So essentially, when we talk about agents, we're talking about something that has to work in a dynamic system. And the first rule to understand if you want to go in that direction during the implementation phase is, can I write a deterministic model that can take care of that problem, that can solve the problem? Most of the times, if you're working in a dynamic system, for instance, you're writing an algorithm, a routing algorithm for Porto, and the algorithm is about going from A to B. That operation is complicated, it's very complex, because you need to understand that you're working in a dynamic system, and even if you write a deterministic algorithm that brings you from A to B, something can happen in the middle. And that something belongs to the fact that we work in a dynamic system. We can have construction sites, we can have, I don't know, people stopping in the middle of the street for no reasons. What happens to your algorithm if it's deterministic? It fails. It cannot bring you from A to B. What you do with agents, just to give you an idea, is telling the agent, hey, I want to go from A to B. I give you the tools, I give you all the things that you need to reach that goal. And then you know how to act if something happens. You know that if something happens from A to B, you can use maybe that specific tool that allows you to ask someone, hey, there is a construction site, where should I go? And so forth, so on. So it's more similar to how we try to think, how we try to reason, if we want to stretch this concept. So it's all about dynamic systems. Now, agents, as I said before, is not something new. I can give you some examples here. Crawling agent, robotic agents, these are all agents. Why I wanna highlight this concept? One example is AlphaGo. Who is familiar with AlphaGo? Who made a lot of noise some time ago? Yeah, right. So AlphaGo was like a very interesting deep learning algorithm that was used to play essentially this Go game that I don't know. But it was really fascinating. I think there is even one Netflix series about it. I'm not sure. And these are all agents. And why I want to highlight this concept? Because the point is, these are agents because they're working in a dynamic system where the rules are a lot, and you cannot write a deterministic algorithm that can help you, once again, to bring you from A to B. So why now? Because, as I said, agents is not new, so why are we talking about agents now? First of all, because it's a buzzword and we have to. But second is because of the LLMs, right? The LLMs are changing the world now. And before, we didn't know how to properly back up an agent. We didn't know how to create an agent that is smart enough to leave this autonomous unit in a dynamic system and say, hey, do something. But now, thanks to the LLM, all the operations, all the things that happen in the dynamic system goes through this process thinking unit. and then the agent knows what to do next, because the LLM is the brain behind it. Of course, I said reasoning many times, and this slide is for me not to go to jail, I guess, because some people get scared when I talk about reasonings. They're like, yeah, but how, what is this reasoning? I don't really believe it. And it makes totally sense. I mean, I also believe that LLMs are not really reasoning, okay? But there's one important point. We don't even how we reason. So this is just a word for me. I'm an engineer. I don't care if you call it reasoning, thinking. I don't really care. But there is this really interesting paper from Apple that says, okay, LLM are not really reasoning and thinking. Depending on what are the benchmarks, you can decide if that's reasoning or not. Definitely, we can say that the famous Turing test, it doesn't help us anymore. It never did, honestly. But I want to give you with something. I want to leave you with something here. The point is that when LLMs are, when the performance of the LLMs are evaluated, we don't do it based on looking at it and say, hey, we put an LLM in the other room, and then we ask questions, and we try to understand if that LLM is a human being or not. This is not how we test the training phase. We usually do it with benchmarks like ARC. And if you don't know what is it, have a look at it, where we show, for instance, images. We show things that are really easy for us, but you will see that LLMs will fail with those information in front of them. So this is how we benchmark performance, not with putting an LLM in the other room. And, but yeah, we call it reasoning, right? And another important point is that you will probably hear this terminology many times. You will hear agentic AI and AI agents. What's the difference? Essentially, I got this question many times, so I decided to clarify this point. AI agents basically refers to those autonomous units that we were talking about. They can take actions, they can live in a dynamic environment. But when we put those agents together and you try to create something bigger, this is when we get agentic AI. So a proper application with agents, autonomous unit, and if we want to clarify, if we want to stretch this concept, there is a difference between AI agents and agentic AI, which is the broader terminology. Now we dive into something a bit more technical. I'll show you a couple of examples of how you can actually build something that works with CrewAI. And why I'm choosing CrewAI, apart from contributing to the package, which is open source, I don't work for CrewAI. I tried all these frameworks. I think it's a good choice, especially if you're diving into this field, if it's new to you, if you want to understand like at a very high level how agents work, how can you create tools for the agents. That's really cool. But there are also some other alternatives. Essentially with CrewAI, the nice thing is that when you import this package, you have at your disposal a lot of interesting things that you don't have to implement. You have agents, tasks. You also have frameworks for creating tools. And you have all these kind of thinking processes that are happening behind the hood. So you don't have to think about, okay, I need to orchestrate how these agents are going to work, how these agents are going to behave. You don't have to do it. It's already done in the framework. And another important point is that is LLM agnostic. All the things we're going to see here are LLM agnostic. We're not based on one single LLM. The solutions that you implement with CrewAI and with other many packages and frameworks are essentially LLM agnostic. You can use any LLM. You can use OpenAI, Mistral, Claude. It doesn't really matter. The structure that you see here is basically based on the framework, but then you can swap the LLM based on your needs. You can also have different agents using different LLMs. How does it work under the hood? In a nutshell, this is CrewAI. We have the process unit, which is in the end an LLM or a set of LLMs. Then we have some tasks. We have the agents that are going to pick the tasks. And then we have some tools that can be accessed to the agents, from the agents. And then we have the crew. The crew is a wrapper for all these things. So in the crew, we're going to put all our agents, and we're going to get an outcome. The core of CrewAI, and this is also one of the things you should keep in mind whenever you want to decide, you have to decide if you want to go with CrewAI or LangGraph, which is also another very powerful package. Who knows LangGraph by any chance? Okay, LangGraph, if you don't know it, check it out because also is a very good alternative for agents. But when it comes with orchestrating agents and to have different roles for different agents and put them together into one single unit, CrewAI does a very good job because you're not just defining one agent, but you're defining a team of agents, and you're saying, you, agent number 1, are going to do this, you, agent number 2, are going to do that, and then you have another agent that is taking all the outputs and creating a final report. So that's the idea behind CrewAI. It's more about roles and which roles you're assigning to the agents. And essentially, when I say crew, I also mean team. So with CrewAI, you build a team of agents. As we just said, we have one agent that is taking care of the planning, one agent that is creating some content, one agent that is calling API, and one agent is evaluating something. And the difference between these and some other packages like LangGraph is that this goes in the same kind of wrapper. So you really focus on the roles that you're assigning to each agent, and that's the core of CrewAI. All right, how can we create one agent with CrewAI? The code is really simple. I hope you can see it. It's not super important. You will get the slides. But essentially, once you import agent from CrewAI, you're going to see something like this. And this class allows you to create an agent, and you have to specify the role, the goal, the backstory, and this is an extra parameter. We don't really care about that. And as you can see here, I'm telling the agent what the agent is about. I'm not adding any other information about what the agent will do. So I'm just saying, hey, you are this kind of agent. Your goal is to summarize documents for me. And your backstory, you have 10 years of experience in summarizing document. It's not too far away. Today I was emphasizing this a lot. It's not too far away from when you prompt engineers, I don't know, I asked this question today, but no one wanted to answer. How many prompt engineers in the room? This is a tough question, right? No one wants to say that we are prompt engineers. Anyhow, if there are colleagues, prompt engineers like me, what we do usually as prompt engineers is writing prompts like, you are a data analyst with 1,000 years of experience, your parents were data analysts, take this data and create an analysis for me. This is how we create prompts. Like, we want to make sure that the prompt is not going to fail. We want to make sure that we get the right data, and we want to make sure that the prompt and the LLM in the end understands exactly what we want to do. And why I'm saying this, because when you take this and you send it to ChatGPT and you get something wrong, maybe that's fine. But if you take this and it's part of a pipeline and you put something in production and this output is the input of another application, you're going to break your pipeline. That's the point. So you want to make sure that the output that you get is exactly what you want. And you want to make sure in this case that the agent is, in this case, about summarizing document. But of course, we're not telling the agent what to do, because we need one more class, which is the task. With the task, we're defining what the agents are going to do. The tasks are for the agent, and once we define what the agent are about, we say, okay, you sales agent, which is something we define here in the task, where we have agent equals sales agent. You sales agent, you will get this task, and this task is about find and summarize the latest and most relevant news on AI. And then we're also defining an expected output. This is also a very powerful thing from CrewAI and some other frameworks, is that you can force the output. This is exactly what I said before. Having the right output from your prompt, from the LLM, is very important when the LLM is part of a very huge pipeline. And then we take these two things, the tasks and the crews, and we throw and the agents, and we throw them into the crew. The crew is our final entity. So when we build the crew, we put all the agents that we have, all the tasks that we have. We decide which process, so we want to execute the process in a sequential way. and then some of the extra parameters, and then we can simply run this. And up to this point, thanks to the crew, the agents, and the tasks, we have something that we can execute. This is already working. You can take this code and it works. And this is our first CrewAI application. There is more, of course. If you want to dive into the package, you have two different types of processes, for instance. So you can decide how deep you want to go in the orchestration steps. For instance, you can decide if you want to run a sequential process, so if you want to execute the tasks in a sequential way, or you can decide to use hierarchical. So you can have one agent that is acting as a manager. This is the same as building a team of people. So you have a manager that is looking at the work of his team, of her team, and is deciding if maybe someone from the team is going in the wrong direction and say, guys, something is not working out, please rethink about your solution and let's try to figure out how we can stay below a certain budget, for instance. And this is when you use hierarchical. Now, let's stop here for a second and imagine how difficult it would be to create something like this from scratch. You have to create a lot of prompts that are being sent to the LLM and say, hey, this agent is doing something wrong, but this other agent is doing something right. And you have to orchestrate everything by yourself. With the framework, you don't really have to think about it. But what you can do is creating an agent which acts as a manager and is overseeing the work of the crew. And then, of course, we have tools, which is, in my opinion, one of the most interesting concepts nowadays, because I think we will spend a lot of time writing tools for our agents and put them on an MCP server, probably. So the core is that agents are nothing without tools. One really interesting example is, let's assume that your company has, I don't know, some business knowledge around how to create emails for the employees that are joining the company. So there are some rules, like you need to maybe check the starting date, you need to take the name. If another name exists with the same notation, you do it differently. Let's assume you have a Python function that does exactly this. What you can do is, if this is going to be part of an agentic AI application, you give this function built as a tool to the agent, and the agent will decide when to use it. And that's where you play a huge role in this. It's not about saying, hey, you are a fantastic data analyst with 1,000 years of experience. That's not our job. Also, if you're very good prompt engineers like me, probably, but our job will be about writing tools that have been used by agents. Here we have a really interesting example. This is a very powerful agent tool, which is called SerperDev tool. Essentially, this is not a custom tool. It's a tool that comes with CrewAI, and is a nice tool because it allows the agent, once we give this tool to the agent in that way, so we define the agent, and inside we say tools, and we put this SerperDev tool, we're essentially giving the agent the possibility to browse the web whenever the agent thinks that is needed. If you're giving instructions to the agent that require the agent to browse the web, this is what the agent is going to do. And then we have some of the extra stuff, for instance, guardrails. So we have also a nice way in CrewAI to create guardrails. Why guardrails are important? Because if you're using all these beautiful things that we have seen for creating, as I said today, LinkedIn posts with NA10, and you have this beautiful pipeline that is creating, by the end of it, a LinkedIn post that will be published on LinkedIn, you want it to be automatized, right? So you want to be like this automatized pipeline. You don't want to do anything on top of it. But you're going through an LLM. You're going through some agents. So these steps are not deterministic. What happens if something wrong goes into the post, like some violence or things like this? This can be very problematic. And with CrewAI, you have these nice decorators that are allowing you to essentially play with the flow of whatever is happening inside CrewAI, and maybe say, hey, this crew created this post for LinkedIn, but there is violence in it. I'm checking with another crew that something is wrong. What should I do? Let's try to recreate the LinkedIn post until we see that is kind of a cache for LinkedIn. Otherwise, we don't do anything. And this is a nice way to kind of copy with the non-deterministic nature of LLMs and agents in general. And another nice concept is conditional tasks. So another way to say, okay, hey, I want to control the flow, whatever is happening inside my crew. I give you a task, but you execute it only if I have, I don't remember here the condition, if some data is missing. If data is missing, you execute this task, otherwise you don't. What's the point of showing you this stuff? The point is that we have a lot of interesting things that we can use to make LLMs and agents a bit more deterministic, so we can build stuff with it. It's not just about showing a 1,000 single Python file on LinkedIn and say, hey, look, I'm working with agents. Of course, you can do that. But when these things go in production, your manager will never allow you to do something that is non-deterministic with LLMs or agents, unless you have some strategies like the ones provided, for instance, by this framework or from other frameworks. So it's really important that you have a feeling that you can actually take out at least a small percentage of that non-deterministic nature out of the LLMs. And yeah, you can also play with the input and the output. I have to be honest, I didn't want to put this slide. This is coming from my workshop, so we can leave it behind. And this is a full CrewAI application. So here we have something that already works. As you can see, there is no prompt engineering. It's pure Python. And there's not even too much code. All the code that you see in the print is only for showing you that you can access the output with Pydantic, if you know Pydantic. You can access as a JSON, so you have a lot of structured way to access the output. Accessing the output from Pydantic, if you know, who knows Pydantic here? Who use Pydantic? So Pydantic is for saying, is for data validation. You say, this output should be potatoes, and I'm going to get potatoes. That's pretty much it. And it's a really powerful tool because with Pydantic, which is a standard now, it's something that is being used, for instance, by Fast API for building endpoints and so far so on. You're basically putting, once again, taking out these non-deterministic features out of the LLM. Here we're creating an agent, we're creating a task, we're putting everything together in one crew, and we're executed, and we're pretty much done. Last but not least, you can do even more. If you want, you can use the synchronous functions inside CrewAI, and you can execute crews asynchronously. So let's say that I have a crew that is doing the onboarding for all of us. Why do I have to do this sequentially? I can also do it in parallel with async.io, and this is already built under the hood, so you just have to use it if you use CrewAI. Now, we move to the skip trip use case, and I look like I'm really good at skiing, not at all, but that's the beauty of presenting on stage, I guess. And essentially what I'm going to show you here is something that I did use for skiing and something that actually brought me here, and is an optimization problem. So when I started skiing, which happened a few years ago, I didn't know anything about it, and I didn't have many friends who were skiing back then. So my problem was, what should I do? I know that you have to go where you have the snow. You can, you know, it's like you can ask ChatGPT, you can do all these things. But there were questions like, okay, who skis here? Who is a skier? Professional? Only one? Okay, but it makes sense. We're in Porto, right? Makes sense. Never mind. Who is surfing? No one? Okay. What do you do? I mean, just kidding. All right. So the point is, it was really complicated to, for instance, answer these questions. And I'm an engineer. I mean, I wanted to control everything and everyone. I'm like, okay, I want to know these things before I go somewhere. I go to Chamonix. I go, and I don't know, like in Italy. And for instance, renting equipment, choosing the best travel option. Some people were coming from Madrid. Some people were coming from UK. I was traveling from Germany. Some people from Italy. And they were like, okay, but we have to go there at the same time. We have to find the tickets, the hotel, the flight tickets, the hotels, the renting spot. And it was complicated for me to put everything together. And at some point, I was like, I think it looks like an optimization problem. So where I have a function that I want to optimize, like some sort of goal function, and I have some constraints. But of course, it was a bit fuzzy. It was not like a real optimization problem that I can solve with Gurobi or Plex, or I don't remember the other one, Cplex. So the problem was, it's an optimization problem, but it's still fuzzy. With ChatGPT or any other providers, it was complicated to work with an LLM because imagine that you throw all this information in it. But what happens when you have something that you're trying to optimize and you're using one single prompt? That you have one single prompt, and inside the prompt you have, if this happens, do that. But if the budget is too high, then you have to take another direction. And all these if then else inside a prompt don't really work well because the LLM get confused, and it's completely normal. Same as trying to create, I don't know if you ever tried, to create a book, like a proper book with Claude. Potentially you get that amount of tokens. You can get that amount of tokens from Claude, but it will never create a book for you. Not because it's not possible, but because it gets confused. You need a better strategy. Maybe you need to use agents. You need to optimize that process. So it gets confused, and at some point it will give you maybe 1-2 pages. And you will think, if you allow me to use this word, that you got a book, but it's not true. So that was the idea. And I wanted to use LLM for something practical. And most importantly, I didn't want to redo this thing every time I wanted to go to ski. So because, of course, I did it once. I was like, maybe I can have an automation around this problem. And what I've done is, first of all, I created my ski destination researcher. So this ski destination researcher is identifying the best reachable destination based on our cost constraints, because of course we had a limited budget. And here I'm showing some of the real agents that I've used, not all of them, but just to give you an idea. Then I had another agent, which is the accommodation agent, and this is of course in charge of looking at where we can stay. Nice thing about this agent is that if you look at the tools, it's using the search tool. The search tool in this specific case is the SerperDev tool that we saw before. What does it mean? It means that this agent is able to browse the web to look for extra information to answer this question. The nice thing also about building agents is in this way is that let's assume that I want to replace this tool because I'm like, I built something for crawling booking.com or whatever. I don't want to use this tool. I can use mine. I can swap it, and I can also add it to this and say, hey, now you also use this tool and you can access booking. And then when you get that information, I don't even think about what you get from booking because you have an LLM under the hood. So whatever you get from booking, you will be able to process it, and the agent will give me something that I can understand. And my effort is not I didn't put my effort into writing what you see here in the agent, but my effort, most of it, goes into designing the whole agentic application and then creating the actual tools that the agents are going to use. And then we have the ski rental advisor, which is also using some tools and is looking at where we can rent the ski gear. And in addition to this, because it's an optimization problem, imagine that I run this in a sequential way. So I found one place where we can go, I find the ski rental, I find something else, I find the accommodation, I find the hotels. But then when I find the hotels, I'm already over, like 100 euros over the budget. What should I do? It's a sequential process. I'm done. So the pipeline is finished. I don't want to execute it like that. I want to have some hierarchical thinking inside. So I want to have an agent, and I want to have a hierarchical process because I want to have an agent that knows that I have some cost constraints. So whenever someone from my team is looking at the accommodation, is looking at booking, is looking at the ski rental gear, the agent, the manager is looking at them and say, hey, I think this is getting very expensive. Maybe you can find something different. Or maybe you, another agent is looking at the hotels, can find another hotel, and maybe we keep the budget below the global constraint, which is the main problem that, of course, I had for this optimization problem. And then we move to the tasks. Of course, I have more agents, but of course, for the sake of the presentation, we're not going to dive into all the things that I implemented. In the tasks, we have the destination finder. This is the task that we give, of course, to the destination finder agent. Here, I'm already putting some data into the task, right? Because this is what is going to happen for real. So this is what we're going to execute. And here, as you can see, I have the names. I'm putting the names. So research a ski destination that is accessible by the names of me and my friends. That we are departing from start locations. So here I'm putting the data that will go into the execution. And then I have also some other constraints. So this is what I'm giving to the manager, for instance. The manager knows that I have some cost constraints, and we have to stay above that budget, below that budget. And finally, as we already know, we put everything together into the Crew, and we create our application. Here we have the manager, destination finder, hotel advisor, rental advisor, our tasks, and as process, we use hierarchical because it's a kind of hierarchical orchestration type of process. And finally, this is the final result. I did go to Chamonix. I didn't like it, honestly. So not because of the agent, just didn't like it. Yeah, we did it. I don't know why my friends are following my advice based on LLMs, actually, but it did work very well, and I was able to execute it multiple times. That's the beauty of it. And now we have a few more minutes, so I can show you something live. So I have an application. No, not this. Okay. Who works with Python here? Who knows a bit of Python? It's not needed anyhow. I should have not asked this question. It's not needed at all. Anyhow, I have some Python code here. We don't really care much about it. But since you know a bit of CrewAI, I can give you a very quick overview of what I've done here. This is a project that is creating... let me make this... So this is a project for creating an AI mock interviewer for interviewing at big companies. So essentially, you open this application and you say, I'm gonna be interviewed at Google. I'm gonna have an interview at Google, and for this specific position, data scientist, I wanna do a very hard interview, something like this. And then you get a list of questions. You can also answer with your voice if you want, not just text. And and you keep getting answers and feedback based on your answers until you want to stop the process. What I have here, we can go through the code very quick. I have some tools. I'm using separate dev tool, essentially because every time I start the interview, I want to look for the information for that specific company. So let's say I want to interview at Google, and I'm looking for some information that I can use for the interview at Google as senior data scientist. Then I have some agents, so the agent for doing the research for around the company. Then I have the question preparer. This is the agent for preparing the question, essentially. Then I have an agent that is evaluating the answer. Then I have a follow-up questioner, which is the agent that will create the follow-up question in the meantime. And we will do this process over and over, essentially. I'll show you how it is done. And then we have the tasks that we're giving to the agents that we have just seen. Essentially, we have a task for doing the research. So given the company name, the role, and the difficulty, give me a question for this type of position. And then I have the preparation task. So given the difficulty, test both theory and practice, comprehensive model, answer that covers all key points, blah, blah, blah. Then we have a task for evaluating our answer, and then we have a follow-up task. Now, I packed everything into a Streamlit application, which is a Pythonic way for creating web applications. So what you see is 100%, 99% Streamlit, and 1% me, and me being good with Python, because Streamlit does everything for you. And this is what it looks like. Essentially, we can start the interview. So we say, okay, Google, software engineer, hard. And we start the interview. Okay, now I can explain you why I have this follow-up question, because I'm using a synchronous function. So what happens is that I ask the agents to get the first question, and once I get the first question, in the meantime, while I'm answering, the second question is also being created as an asynchronous function. So you don't see, you see this waiting time only when you start the application, but then the waiting time is happening under the hood for the second question, and it happens over and over. So you get the question, you answer, and then the follow-up question is being created, and you continue this process until you stop the application. What can we also look at in the meantime is the logging. The logging in CrewAI is amazing because you get everything from the agent. So you get all the thinking process. You see that one agent is thinking in this way, is using this tool, another agent is creating that specific output and is using another tool, and so forth, so on. So the output from CrewAI is amazing. I hope it works. I think the connection is not great here. Okay, design a system that I know nothing. Okay, of course, this is not the right answer. It will say that it's not the right answer. Now it's evaluating my answer against the right answer, which has been created already. And you will see that once I get the question, it's a bit slow because the interconnection is a bit slow. Once I get the answer, you see here, this is the feedback, and it's actually explaining why it's wrong. And I already get the second answer, so I didn't have to wait because it was happening under the hood as an asynchronous function. And so forth, so on. If I want, I can use voice. I'm using OpenAI Whisper if you're interested to record the voice and turn it into text. And yeah, that's pretty much it. I hope that this backup presentation was kind of satisfying. I'm just kidding, it was great. Thank you. Thank you. How does it work? Questions? No one told me. Okay, if you have questions, I will repeat it. Only easy questions. No worries, only easy questions. It's all happening locally. Yeah, it's a Python package, and of course the LLMs are not local LLMs. But if you want, because I do this with my Raspberry, I have some local LLMs that I'm running at home. So if you want, you can also run your local LLM, and everything stays local. The beauty of CrewAI is that it's LLM agnostic. So if you want to switch, what you have seen is pure Python CrewAI code. But it's open source, it's local, and then if you want to swap it with another LLM, you can do it, or you can have even a local LLM on your Mac. You can do a lot with local LLMs on your MacBook. Yeah.
Okay. So the question is, how can we connect it with some other LLMs, like let's say OpenAI? And what it was demonstrated, it is using its own internal CrewAI LLM, right?
No. Here I'm using OpenAI, which is the default LLM. If you don't, if you don't choose like an LLM, the default one is OpenAI. The way it works is that I have an OpenAI key saved as environment variable on my machine. And this is being used by ChatGPT, by CrewAI. Another option is that you explicitly say, use this LLM. For instance, today the workshop, someone used Claude, someone used Open Router. You can use whatever you want. And you have to specify that in the code. You have to write like LLM equal to the LLM you want to use with you need an API key, and then you give this LLM to the agent. This is also a very good question, because if you want, you can have different agents using different LLMs. So maybe you want one agent to be really good at coding and use one specific LLM. Or a common scenario is that for kind of dumb agents, you don't want to use ChatGPT 5. You want to use, I don't know, ChatGPT 4 or Mini or something like this. If it's an agent that is only creating a report. So, yeah.
Okay, thank you.
Yeah. So the way the agents interact between each other is mainly driven by the library itself. So you can imagine that under the hood, on top of what you write in the agents and the tasks, under the hood there would be, this goes into a prompt, and like a lot of different prompts, like, hey, this agent is about this, and is speaking this task. Try to find, this is one of the prompts, trying to find the best tool that this agent, based on the available tools, can use to achieve that task. Maybe the answer is, there are no tools. Okay, then do your best with the information that you have. And then you have another prompt. There is a manager. And all these prompts goes together. And this is what you don't have to implement, because it's done under the hood with CrewAI. You can have a glimpse of this process if you look at the output of your CrewAI application, what we were looking at before, which is this. So if you look at this, you see exactly what is happening. This task has been assigned to company research agent. This agent is using this tool and is creating this output. Yeah. But if you want to do it like full deterministic, you don't use LLMs. You do it by hand, like on paper. Yeah. Anything else? Also, tough questions. I was kidding. If you have a very hard question, we can kind of.
So my question is, can the agents inside the crew be scaled separately from the actual crew? So that might be use cases that you might want different resources for different agents. Is that possible, or you need to scale the whole CrewAI as a whole?
So the agents in CrewAI are always part of a crew. In the end, it's a Python application. What I can see is maybe you can rely on these new MCP servers, this model context protocol, where the MCP server is simply a new way of building tools that it can be accessed through some sort of contract. You have a tool laying in a server, and you try to access the tool. That tool, whatever it does, can scale based on the server where the tool is running. So I guess maybe this goes in the direction of what you said. Yeah.
Thank you.
Yeah. Yeah. The lady is bringing the microphone. She's really upset if you don't use it.
Can you use this for other kinds of generative AI, for other types of workflows, like generating video, images, stuff like that?
Yeah, you can. You can. It depends on, you have a lot of different connectors and classes in CrewAI. Depends on what you can I mean, now CrewAI is kind of mature, and you can use a lot of features that are coming from the LLMs. For instance, creating images. I think there's also something with some video stuff. It depends on the community. If they build it, maybe you have a connector for it. That's, yeah.
All right.
So I've never tried with video. With images, for sure, because, you know, the process of thinking can also happen around images. You can take that image, turn it into text, and then reason around that text. So it's easy for the images. Maybe for the videos it's a bit more complicated, but yeah, I'm not sure. I think it's possible.
All right. Thank you. Thank you.
All right. Thank you. Thank you. Thank you.